Hello, this is question 7 on your November 2021 paper 2 from AQA. It's a circled question. It's quite simple, but maybe you struggle with the last part. A circle has this equation, this one, and we have to find the coordinates of the center. When we have the circle written this way, it's not too easy to see the coordinates of the center, so what we do always is complete the square in the x side and in the y side. That way, the center is going to be half of that, so 3, and half of that, which is 4. Why? Because we are writing, if we complete the square with the x, we have x, and we are going to do it because we need it anyway. So x minus half of that square minus 3 square, which is 9, plus y minus a half of this, so 4 squared minus 4 squared, which is 16, equals b. And that means the coordinates of the center, once I have the equation written this way, and I can pass all the numbers to the other side, the coordinates of the center are going to be 3, 4. Yeah, and this is 25 plus p. So the coordinates of the center are 3, 4. That's the first part. That's why I say that maybe you are able to see straight away here, because it's half of x and half of y. Find the radius of the circle in terms of p. So the radius of the circle, once we have the equation written this way, is going to be the square root of that thing. So the radius of the circle is root 25 plus p. Yeah. Then the circle intersects the coordinate axis at exactly 3 points. And this is where you have to think a tiny bit. So the center of the circle, we say, is 3, 4. So I'm going to do kind of quick sketch. It's not going to be good because it's difficult. So 3, 4 is a point that is somewhere here. Yeah. So y is greater than x, which means if it's going to touch the coordinate axis in 3 points, is going to be tangent to one and cutting the other. If it's tangent to this one, it would be too small to cut this one. So it must be tangent to this one, and that way we'll cut the other two. The other axis in 2 points. So if we have the circle doing something like this, that would be 1, 2, and 3 points. Yeah, but if it's tangent to this one, it won't touch the other one. This is one possibility, and another possibility that is difficult to think, I think, many of us with me, is that it can pass the origin. So we have our point here, and we have a circle that passed the origin. Yeah, so that would be another option, because again we have 1, 2, and 3 points. That's where they ask us 2 possible values of p, because this is going to be 1 and this is going to be the other. Yeah. So let me if we have the first situation, the circle must be tangent to the x-axis, and the equation of the x-axis is y equals 0. So the intersection between that line and the circle must have only one solution. So that's what we are going to force. X squared plus y squared minus 8x minus 6y. I'm doing... No, it's the other way around. So 6 and 8. 6 and 8 is p, and the x-axis must have only one solution. So if I solve simultaneous equations and I substitute my y into the first one, I have x squared minus x, say 6x is p, and this must have one solution only. So this is a quadratic, I can write this way. So my discriminant must be 0. Must be 0, which means b squared is minus 6 squared, which is 36, minus 4 times 1 times minus p is going to be plus p equals 0, which means that p is going to be minus 36 divided by 4, which is minus 9. So this is one possible value of p. The other options, so this was option 1, option 2 is that it passed the origin, therefore cuts in again in 3 points. If it passed the origin, 0, 0 must satisfy the equation. So that means 0, 0, 0, 0 must be p. Yeah. So the other option is that p So 0, 0 is in the circle. That means that P is 0. Yeah. Yeah, and P is not the radius, yeah? Remember, because the P is here alone, it is not the radius. The radius is 25 plus P, so the radius would be 5, yeah? And that's all with this question. Those are the two possible values of P.